This is the fourth equation to calculate the entropy change, or delta S. This equation is derived from another equation we have learned in class. Generally, we use this equation to calculate the entropy change for a chemical reaction. But this equation can also be used to calculate the entropy change of a physical process. Let me use two examples to show you how to calculate the entropy change of a chemical reaction by using equation number 4. The general idea to calculate the entropy change with equation 4 is to calculate the enthalpy change and the free Gibbs energy change by using the standard enthalpy of formation and the standard Gibbs energy of formation. Then we plug in both delta H and delta G and the temperature. We can calculate the entropy change of the reaction. Let me show you the details. We will calculate delta H because this is delta H for this reaction occur at standard conditions. So we will put down delta H reaction and circle. What we need to do is we need to find the standard enthalpy of formation of the products and of the reactant. We add the standard enthalpy of formation of all products together. And we also add the standard enthalpy of formation of all reactants together. Then the difference will give us the standard enthalpy of reaction. From the table, we find the standard enthalpy of formation of sodium carbonate solid is negative 1,130.9 kilojoule per mole. The coefficient in the balanced chemical equation for sodium carbonate solid is 1, so we multiply 1 mole. The second product is carbon dioxide gas. We also look up the table to find the standard enthalpy of formation of carbon dioxide gas, which is negative 393.5 kilojoule per mole. The coefficient in the balanced chemical equation for carbon dioxide gas is also 1 mole. The last product of this reaction is water liquid. Again, we will look up the table to find the standard enthalpy of formation of water liquid is negative 285.83 kilojoule per mole. And the coefficient in the balanced chemical equation for water liquid is 1, so we multiply by 1 mole. We only have one reactant, which is sodium bicarbonate. Again, we will use the table to find the standard enthalpy of formation of sodium bicarbonate solid, which is negative 947.7 kilojoule per mole. We need to minus the reactants. The coefficient for sodium bicarbonate in the balanced chemical equation is 2, so we multiply by 2 moles. Mole cancel, mole cancel, mole cancel, mole cancel. The unit we get for delta H reaction is kilojoules. If you punch all numbers into a calculator, you will get 133.87 kilojoules. We will use a similar method to find the Gibbs energy change for the reaction. We also call that the standard Gibbs energy of reaction. We will add the standard Gibbs energy of formation of all products together minus the sum of the standard Gibbs energy formation of the reactant. The standard Gibbs energy of reaction is 24.07 kilojoules. After we get the standard enthalpy of reaction and the standard Gibbs energy of reaction, we just plug in both to this equation, and then we will calculate the entropy change for this reaction, which we call the standard entropy of reaction. And the temperature we need to use should be in Kelvin. Then let's convert the degree Celsius to Kelvin first. Then we plug in here. And the answer we get from a calculator should be 0.368 kilojoule per Kelvin. Let's look at the second example. We have 2 moles of ozone. We'll convert to 3 moles of oxygen gas. We will use exactly the same method. We will calculate the standard enthalpy of reaction. We find that we do not have the standard enthalpy of formation of oxygen gas. But remember, for all the most stable elements, they have 0 standard enthalpy of formation. So we should have 0 minus 4 ozone gas is 142.3. The unit is kilojoule per mole, and then we have 2 moles, so we multiply by 2 moles. This will cancel. The answer we get will be negative 284.6 kilojoules. We use a similar method to find the standard Gibbs energy of reaction. For the most stable element, the standard Gibbs energy of formation is 0. So oxygen gas has 0 standard Gibbs energy of formation. 0 minus, this is negative 163.4 times 2 moles. 326.8 kilojoules. Then we use this equation to calculate the entropy change. Because this is a reaction at standard conditions, so we call this delta S the standard entropy of reaction. I copy the equation. This will help me to memorize the equation. If you punch all numbers into a calculator, we will get 2.055. The unit is kilojoule per Kelvin.